Hello. Today we'll be looking at factoring. Our objectives are as follows. We would like to know what is factoring, what is greatest common factor, and how do we identify the greatest common factor. We'll be looking at factoring in general, how to factor a polynomial, then factoring by grouping, factoring trinomials, and some special factoring. So factoring is a process of writing a polynomial as a product of prime polynomials. So it is the way to rewrite or write as a product of prime polynomials. Okay. So we know what product is. Product is the multiplication. Okay. So we want to take a polynomial and we want to rewrite that polynomial as product of prime polynomials, meaning we want to take that polynomial and write it as pieces of multiplications. Okay. So for example, if you have 6, okay, 6 can be written as 1 times 6, or 1 times 2 times 3. So when you write as a product, that's what's called factoring. But the key point is that whenever you say it's factored, it has to be prime polynomials. Okay. So when we speak of a prime polynomial is a polynomial that does not factor using integers, meaning it cannot be factored anymore. For example, x cubed minus 3 is considered prime because there's no common factor between x cubed and minus 3. So before we get into the factoring, we have to figure out what is GCF, okay? Greatest common factor. So what is GCF? The greatest common factor, okay, abbreviated GCF, for a polynomial is the largest monomial. And if you recall from when we looked at polynomial, a monomial is a single term polynomial that divide each term of the polynomial. Yeah. For example, if we have 25x to the 5th plus 20x to the 4th minus 30x cubed. Okay. Now let's look at the coefficients first. Let's look at these numbers first. What's the GCF of 25, 20, and 30? Okay. What is the largest number that goes evenly into each of those numbers? So if you think about this, 5, okay, the GCF will be 5 because 5 goes into 25, 5 goes into 20, and 5 goes into 30. Okay? It has to go into all the terms of the polynomial. For example, 2 will go into these two terms, or 10, but it will not go into the first term. So 10 cannot be the greatest common factor. Okay? When we're looking for the greatest common factor, it has to go into all of the terms. Okay? Every single term. So we got it for the number, the coefficients. How about the letters? Now, an easy way to look at this is that the letters must appear in each term. So there's an x term here, there's an x term here, and there's an x term there. If the letter appear in each term of the polynomial, then you will take the letter with the lowest power. So in this case, it will be x cubed. Okay? X cubed. So the GCF here is 5x cubed. Now, if you take out 5, we said it has to be written as a product. So the GCF will be the first polynomial, 5x cubed, times what? Now, if you think of this to find the inside of the parentheses, if you take 25x to the fifth and you divide 5x cubed, this will give you 5x squared. So that first term in here will be 5x squared. Okay. If you do that again, move on to the next term. What is plus 20x to the fourth divided by 5x cubed? And that will give me 4x. So we have here plus 4x. And if we do that again, what is minus 30x cubed divided by 5x cubed? Well, the x cubes will cancel out, leaving me just minus 6. And that becomes minus 6. Okay. Now, as a check, what you can do, if you multiply this by every single term in there, this is sort of your check. Because if you multiply this out, you will see that you will have 5 times 5 is 25. X cubed times x squared becomes x to the fifth. Then if we multiply 5 times 4, we get positive 20. And x cubed times x becomes x squared. And 5 times minus 6 becomes minus 30. There's no x here, but there's an x cubed here, so that you have to bring down the x cubed. And notice this here is exactly what we had at the beginning. So by multiplying it out, multiplying your factors, okay, you should get back the polynomial you started with. So we can say that 25x to the fifth plus 20x squared minus 30x cubed, okay, is the same as 5x cubed times 5x squared plus 4x minus 6. This here is called the factor. Okay, that's called our factor. Now, you also learned that this here is a special polynomial, right? We saw that when the highest power is 2, and it decreases by 1, and there's 3 terms, it's called a trinomial. So later on, we'll see that there are ways we can factor trinomials. Yeah? There are ways that we can factor out trinomials. And you will see for this trinomial, okay, that's highlighted in blue, that this cannot be factored anymore. So this will be called a prime polynomial, or a polynomial that's irreducible. Okay, when it's prime, we can say it's irreducible. It cannot be reduced anymore. So let's look at another example. Suppose I ask you to factor 6x cubed minus 4x. So step 1, okay, step 1, we can write this at the side. Step 1, find the GCF. So what's the GCF? Goes into 6 and 4. What's the largest possible number? Well, 1 goes into 6 and 1 goes into 4, but that's not the largest. If you look at 2, 2 goes into 6, 2 goes into 4. Okay? Well, let's try 3. 3 doesn't go into 6. 3 goes into 6, sorry, but 3 doesn't go into 4. And then finally, the largest possible number it could be is 4. 4 is divisible by 4, but 4 is not divisible. 6 is not divisible by 4 evenly. Okay? You'll get a fraction. So trying, we saw that the GCF is 2. Okay? GCF is 2. Now let's look at the letters. We have letters here. We have x here, and we have an x term there. So x appears in both terms. And we said we can pick it by identify the one with the lowest power, which is just x to the 1 power, if you want to say. Okay? So that's my first polynomial. The GCF will always be the first polynomial. So what 2x times what will give me what I have. Okay? And step 2 now, step 2, take each term of the polynomial, right? Take each term of the polynomial. So what is 6x cubed and divided by the GCF, 2x? That will give me 3x squared. So in here I have 3x squared. Okay? And then I do the same thing again. What is minus 4x divided by 2x? So the x's will cancel out, and minus 4 divided by 2 will give me minus 2. And here we get a minus 2. So this here is called a factor, and this here is also called a factor. Okay? And you can do your check. You can perform a check. If you multiply those two factors, if you take 2x and you multiply it by 3x squared minus 2, 2x times 3x squared becomes 6x cubed. And 2x times minus 2 becomes minus 4x. And that's exactly what we started out with, right? 6x cubed minus 4x. Yeah? So this is our check. Okay? Let's look at another example. So how about if I ask you to factor 5x cubed minus 15x squared? So the first thing we want to do is to find our GCF, if possible, right? Because not all polynomials can be factored. So let's look at our GCF. GCF, what goes into 5 and 15, the largest possible number? Okay, so if you think about that, 5 goes divisible by 5, and 5 goes into 15. Okay, so the GCF will be 5. And then we look at our letters. There's an x term here, and there's an x term here. So then we can take out the lowest power, which is x squared. So if we take out 5x squared, what will be left? To find out what is left, I said take each term of the polynomial, right? So here was our step 1, GCF. And then step 2, we'll take 5x cubed and divide it by 5x squared, the GCF. That will give me 5x. So 5x will be part of the second factor. And then we do the same thing again. We have minus 15x squared, and we divide that by 5x squared. And this will give me minus 3. The x squared will cancel with the x squared, so we have minus 3. Okay. Another example, and don't forget, you can do your check, right? You can do your check. So if you multiply 5x squared times 5x minus 3, 5x squared times 5x becomes 25x cubed, and 5x squared times minus 3 becomes minus 15x squared, which is exactly what we had. Okay. So even if I do not say do the check, you should always do a little check to make sure that it's correct. Now, the next example I have, how about if I ask you to factor, okay, 4x cubed y plus 7x squared y squared. So step 1 is to we'll identify our GCF. So what is the GCF? GCF Well, if you look at this, the two numbers that I have is 4 and 7, okay? And there's no number that goes into 4 and 7 evenly. That same number, other than 1, okay? No number. 2 goes into 4, but 2 doesn't go into 7. So in terms of 4 and 7, there is no number. Now we look at the letters. We have an x here and we have an x here. So we take the one with the lowest power, which will be x squared. But if you look again, we have more letters. We have a y here and we have a y square here. So we take the one with the lowest power, which is just y. So our GCF is x squared y. Now what's left, we do the same thing, okay? To scrap work, what is 4x cubed y divided by x squared y? So the 4 is left, the x cubed and the x squared becomes x, and the y cancels out. So here we have 4x. And then we do the same thing, 7x squared y squared divided by x squared y. So here the x squared cancels out, leaving you with 7, and y squared divided by y leaves me with just y. So we have plus 7y. So just note that when you find your GCF, the GCF could consist of more than one letters, or only a number, okay? Over here, my GCF was a combination of a number and a letter, okay? Combination of a number and a letter. I think the first step too, it was a combination of a number and a letter, okay? How about if I do another one? Factor, if I ask you to factor 11x squared or cubed plus 7y to the fourth, okay? So what's my GCF? Well, what number goes into 11 and 7? And if you notice, these are both prime numbers. So there's no number other than 1 and itself that will go into 11 and 7. Okay? 11 is prime, only divisible by 1 and itself. 7 is also prime. So in terms of the number, there is no number. Now let's look at the letter. There's an x cube here, but there's no x cube on the second term. There's no x cube here. So x is not a GCF. And then if we look at the letters again, there's a y cube here, but there's no y cube on this side, or y to the fourth, sorry. So in this case, there is no GCF, no GCF. So this polynomial, 11x cubed plus 7y to the fourth, is what we call a prime polynomial. Meaning, this polynomial cannot be written as a product of polynomials, okay? There is no part of polynomial. You cannot break this up and write this as a product of polynomials. So sometimes you will see polynomials that cannot be factored, okay? When they cannot be factored, we call them prime polynomials or irreducible polynomials. So here's another example of factoring. So how about if I ask you to factor, okay? I would like you to factor for me 5 parentheses x plus y plus x times x plus y. So if we look at this carefully, look at the numbers first. So here we have a 5, and over here, in the second term, we have an x, okay? So for the number's sake, there is no common number. But if you look at this carefully, if you look at this side, you have in parentheses x plus y. And on this side here, you have an x plus y. So in this case, we do have a GCF. We do have a GCF, but a GCF is not a single term polynomial, it's x plus y. Okay? No one said that the GCF has to be a number and a letter. Okay, the GCF could be a combination of the sum or difference or product of number and letters. Now, don't be afraid of this because we know once we get the GCF, that is our first polynomial. So our first polynomial is x plus y. The question is what goes in there? Well, let's look at this. Remember what we did before. We took the polynomial first term, 5 parentheses x plus y, and if we divide it by the GCF, which is x plus y, notice that this will cancel with that, leaving you with just 5. So in here, we have a 5 left. Okay? And if we do the same, x times x plus y, the second term of the polynomial, and we divide that by our GCF, which is x plus y, this will cancel with that, leaving me with just x. So here we have plus x. So now we have two factors. This is our first factor, x plus y, and this is our second factor, 5 plus x. Okay? So these here is what we call factor, and in terms of, think of them as a term of a group, which is what we're leading to. Okay? Factor by grouping. So in factor by grouping, you'll notice in many times that your GCF will not be a single term. It will be a binomial. Okay? And I'll show you why we said this is leading towards factor by grouping, right? Let's look at another example. So, example. If we have, and I ask you to factor a squared b squared plus b squared plus 8a squared plus 8. Now, if I ask you, what is the GCF of this polynomial? Because this here is a polynomial, right? This is a polynomial. So what's the GCF? What is the GCF? Remember, GCF, if you say it's a letter, the letter must be in every single term. So there's a here, there's no a here, there's an a here, and there's no a here. So a is not part of the GCF, okay? A is not part of the GCF. If we do this again, okay, and we look at the b's, there's a b here, there's a b here, there's no b here, there's no b here. So b is not part of the GCF. Okay. So what do? Well, if you notice here, and here's a little hint, this polynomial has 4 terms. 4 terms. Okay. And if you look at this, the first two terms have something in common. And the last 2 terms also have something in common. Okay? The first 2 terms, if we look at just the first 2 terms, in this portion here, we do have a GCF of b squared. And in this portion here, we do have a GCF of 8. Okay, they both have 8 in them. So what we do, we break this problem into 2 groups. Hence, factor by grouping. Okay? So if we take out b squared, from the first group, then what will be left is the a squared and then plus 1. So let's see how we got that. Remember what we said. Once we found the GCF, we take the first term, a squared b squared, and divide it by the GCF. This will give me a squared. And then if we do the same thing again, what is b squared divided by the GCF b squared? Anything divided by itself is 1. And that's where I'm getting this 1 from. Okay? Anything divided by itself is 1. It's very common we say it cancels out, but no, anything divided by itself is 1. Now, let's look at the second part of this, okay? Let's look at the second part. There is a GCF of 8, okay? And what I like to do is take whatever this sign here is, I always take it to the GCF. So it's plus 8. If this sign was a negative, then you would write a negative here, okay? Plus 8. Now let's do the same thing. What is 8a squared divided by 8? This will leave me with a squared. So I put a squared here. And then what is 8 divided by the GCF, which is 8? Anything divided by itself is 1. So I have plus 1. Now, look carefully. Look carefully, right? What you will observe is that this parentheses is the same as this parentheses. And that is generally the case when we perform factor by grouping. If it's not the same, go back and check your work, because more than likely you did something wrong. Now, because these two parentheses are the same, we can say that here, these are GCF again. Okay? And that's why above I said this was leading to factor by grouping, because when the parentheses are the same, we factored it out. So if we factor out a squared plus 1, what do we have left? Well, we have a b squared that's left in the first term, and we have a plus 8 that's left in the second term. So these are the two factors for our polynomial which we started out with. Okay? Those are my two polynomials. And this is what we call factor by grouping. Let's look at another example. Factor. How about if I give you 3x to the 5th plus 6x cubed minus 2x squared minus 4. Okay. So remember, whenever you hear factoring, the first step is always look to see for GCF. Okay, GCF. So if you notice, there's a 3 here and a 6 here, so they do have something in common. But then we got a 2 here, so then we're out. Okay. There's no number that goes into 3, 6, 2, and 4 evenly other than 1. Okay. So if we look at the x's, there's an x term, an x term, an x term, but there's no x term here. So here we have a 4-term polynomial, right? 4 is the hint. We have a 4-term polynomial, and there's no GCF. But let's see what happens. What happens if we break this up into 2 parts? If we take this portion first as one polynomial, and then what happens if we take this portion as our other polynomial? Okay. So what do we have as the GCF for this polynomial? GCF. Well, the GCF, we do have a 3, and since they both have x's, we take the one with the lowest power, which is x cubed. So if we factor out 3x cubed, what do we have left? That should give us x squared plus 2. And you may want to do this scrap work on your side, right? Well, how are we getting this x squared here? Well, we're taking 3x to the 5th, and we're dividing by our GCF. 3 divided by 3 is 1, and x to the 5th divided by x cubed becomes x squared. Okay, x squared. That's where I am getting my 1x squared from. We don't need to write the 1. And then I do the same thing. What is 6x cubed divided by 3x cubed? So the x cubed will cancel out, leaving me with just 2. That's where I'm getting this 2 from. So this is our scrap. When you get the hang of this, you don't have to do the scrap as I'm showing you now. Now, on this side here, what's the GCF? Well, we have a 2 here and a 4. So GCF is 2. Here we have an x, here we don't have an x, so we can't take out a 2. So I said you always take this sign with it, so it's minus 2, okay? Now you have to be careful here. If you take out a minus 2, what's left? Let's do the scrap. So what is minus 2x squared divided by minus 2? So the minus 2 and the minuses and the 2's cancel, leaving you with just x squared. So here we have x squared. And then you have to be very careful. What is minus 4 divided by minus 2? 2 negatives becomes, if you divide, the result is positive. 4 divided by 2 is 2. So the answer is plus 2. Okay. Notice what happens. This sign here changed. Okay. That sign changed. So observe again, this parentheses is the same as this parentheses. So once again, we do have GCF. GCF is x squared plus 2. And if you take out x squared plus 2, what do we have left? Well, you will have this parentheses here left, or the outside here, which is 3x cubed. And then you'll have a minus 2 left, minus 2. And here are your factors of that polynomial. Okay? As a product. Once again, factoring is a product. And if you multiply these two guys, you will see that you will end up back with this polynomial. Okay? So now let us look at factoring now. Factoring quadratics. Okay? Remember, a quadratic, okay, quadratic is written in the term ax squared plus bx plus c. So it's a 3-term polynomial, right? 3-term polynomial where the highest power is 2. Okay? So if I ask you to factor x squared plus 2x minus 15. So there's a few ways to factor quadratics. We have what is called a guessing method. And since we're looking at this, I'm not going to discuss guessing method. You can also perform factor by grouping, and some of you use what is called a square, right, or a rectangular to get the factors, which is really a guessing method also. Okay? Or what is called a trial and error method rather than guessing method. Now, in quadratics, and the reason I'm showing you the factor by grouping is because this will help you later on for more complicated polynomials where the a coefficient here is not 1. If you notice, a is 1. So note, right, note a is equal to 1, b is equal to 2, that's your b, and c is equal to minus 15. Okay? Now you should always observe what is a, b, and c, because later on when we solve this, we'll have something called the quadratic formula. You have to know what is a, b, and c. So we will use the, or factor by grouping. Factor by grouping says always multiply A times C, known as the AC method also, okay? So A is 1 and C is minus 15. So the product is minus 15, okay? Step 1, multiply A times C, okay? Step 2, we will look for the factors of the result from step 1. So what are the factors of minus 15? Well, start out with 1. 1 times 15. Now, because this is minus, one of these here has to be minus. How do you know which one is minus? Look at the B. Look at B. If B is positive, the smaller number will always take the minus. If B is positive, the smaller number will carry the minus. Okay? There is no 2, so 2 times nothing will give 15. 3 times 5, the smaller number should carry the minus. 4 times nothing. 5 times 3 is the same as 3 times 5, so we could ignore this. Okay? And once you list a few of them, we check. Okay? We check. So what is step 3 now? Step 3. Look at all your pairs. Identify a pair, right? Each one is a pair where the sum of the two numbers is the same as B. Remember, B was equal to 2, right? Recall, B is equal to 2. So let's try this. What is minus 1 plus 15? That does not equal to 2, right? That is equal to 14. So this one is out. Okay? Let's do what is minus 3 plus 5. That does equal to 2. So this one will work. So we want to choose this one here. Okay? So remember what our polynomial was, right? X squared plus 2x minus 15. Our polynomial was x squared plus 2x minus 15. What I'm going to do, I'm going to replace this 2x here with the two factors that we got. So x squared minus 3x plus 5x minus 15. These were the two numbers you obtain over here. Okay? Those are what you get the two numbers from. Now notice you have a polynomial with 4 terms. So you can perform factor by grouping. Factor by grouping. So what's the GCF here? And what's the GCF on this side? So notice your GCF on this side here is x, and the GCF on this side would be sign is plus, so plus 5. Okay. If you take out x from what we call the left-hand side, you'll have x minus 3. If you take out the plus 5, you will have x minus 3 also. Observe once again, this will always be the same, okay? This is the same as this. So we have GCF again. GCF is x minus 3. And if we take out x minus 3, we have x plus 5 remain. Okay? So x minus 3 times x plus 5, that is equal to x squared plus 2x minus 15. And you will notice that if you multiply this, yeah, this will be your result. You can try that. Yeah, let's try it. X minus 3 times x plus 5. X times x becomes x squared. X times a positive 5 becomes plus 5x. Now we move to the negative 3. Negative 3 times x becomes negative 3x. I'm foiling here. Negative 3 times a positive 5 becomes negative 15. If you combine the two like terms, we get x squared plus 2x minus 15, which is exactly what we had started out with. Okay? So here is our check. Now, like I said, factor by grouping will work regardless the value of a. Okay? The guessing method would also work, but your guessing method becomes a little bit more complicated. Okay? When a is not equal to 1. Right? And we'll see in a few examples. Okay. Let's look at another example. Let's factor 3x squared plus 10x minus 8. So remember, the first step in factoring is look for GCF. This is very common where students overlook this. Always look and see if there's a GCF. Okay? Because if you leave out the GCF, your final answer will be wrong. Now, there's nothing common between 3, 10, and 8. Okay? This here doesn't have 4 terms. And if you look at it carefully, you will see that this is quadratic. The highest power is a 2, followed by a 1, followed by x to the 0 power. This is quadratic. Okay? This is quadratic. So, if it is quadratic, a is equal to 3, b is equal to 10, and c is equal to minus 8. Okay? Remember, we always multiply a times c, which is 3 times minus 8, and that is equal to minus 24. And now we look for factors of negative 24, okay? Always start off with 1. 1 times 24, 2 times 12. Now, since this is negative, look at the value of b. If b is positive, the larger must be positive, the smaller will be negative. Okay? 3 times 8, this. And let's do a check. What is minus 1 plus 24? This is equal to 23. So this one is out. No good. What is minus 2 plus a positive 12? This is equal to 10. That checks because b is 10. So what we're going to do, we're going to replace this here. We have now 3x squared, rewrite 3x squared, okay, minus 2x plus 12, and this is equal to, or minus 8. Now it doesn't matter, class, if you write the negative 2 first, or if you write the 12 first, okay? You could have switched the order, it doesn't matter. And notice also I left out my x here. This should be an x, right? Because when you combine these two, you must get back positive 10x. Okay? We want to make sure we get back that middle. Okay? Now, let's factor by grouping. Let's see what's the GCF on this side versus what's the GCF on this side. So the GCF on this side here, GCF, there's nothing common between 3 and 2, so it will just be x. And the GCF on this side here, since this is a plus sign, plus 4. So if we take out x, we have 3x minus 2 plus 4, right? Plus 4. If we take out 4, we get 3x minus 2. Notice my parentheses are the same, so that more than likely I'm doing something right. So the GCF again is 3x minus 2. And if I take out 3x minus 2, I will have left x and a plus 4. So here are the factors, the two factors. Notice in this problem that the value of a wasn't 1, the value of a is 3. And hence that's the reason I like factor by grouping. So you don't have to learn a different method when a is 1 or when a is 3. It does not matter. Okay? Doesn't matter. If you look at another example, if I ask you to factor 2x squared plus 14x plus 24. Now, remember you're factoring, and the first step in factoring is to look for GCF. So what is your GCF? GCF here is 2. If you take out 2, you'll be left with x squared plus 7x plus 12. Now be very careful. You should get into the habit of knowing now what a quadratic is by seeing it. Here you have a quadratic. So now you have to see is, can you factor that quadratic? Okay. So anytime you think that you're finished your problem, look at the factor. This is called a factor. This is called a factor. Look at your factors and see, okay? Look at the factors and see if it can be factored more. That's the point. So if we look at x squared, right? If we look at x squared plus 7x plus 12, we notice that this is a quadratic. So a here is 1, b is 7, and c is equal to 12. If we multiply a times c, this is equal to 1 times 12, which is positive 12. And the factors of positive 12 is 1 and 12, 2 and 6, 3 and 4, 4 and 3 is the same, so we could ignore it. Now, is there any pair that adds up to be whatever b is? B is 7. And notice that this pair here will work. So we can say that 2 times x squared plus 3x plus 4x plus 12. And now we perform factor by grouping in here. Okay? Perform factor by grouping in here. So if we bring this 2, just keep bringing it down, the GCF here is x. So if we take out x, we'll have x. Let me leave some room. Bring the 2 down. If we take out x, we'll have x plus 3. The GCF on this portion here okay, on this side is plus 4. So if I take out a plus 4, I have x plus 3. Okay, this is for the 2 on the outside here. Now notice, as I said, we have a x plus 3, x plus 3. So if you take out, leave the 2, x plus 3, we would have x plus 4 left. Okay, x plus 4. So finally we have 2 parentheses x plus 3 times x plus 4. Now if you didn't take out this 2 at the beginning, if you did not take out this 2 at the beginning, what would happen at the end, the 2 would have been embedded in here. So you would have had 2x plus 6 times x plus 4, or you would have had x plus 3 times 2x plus 8. And these are not prime polynomials. Okay? So these answers would have been wrong. Okay? Can't. So keep in mind, first step in factoring is that you have to find your GCF. Let's look at another example. So keep in mind, right, the more you do this, okay, the better you become at it. And factoring is very unique because every problem is different. Okay. How about if I ask you to factor 2x squared plus 13xy plus 15y squared? Okay. Now, you will notice that this looks very similar to a quadratic. If there was no y in this problem, okay, then you probably would say that this is a quadratic. Okay, so we can think of this as the same way as a quadratic. First, look for GCF. You will notice that there is no GCF because there's no nothing common in every single term. Okay, so we can think of this, so we can say, well, a is equal to 2, b is equal to 13, and c is equal to 15. Okay, and if we multiply a times c, this becomes 2 times 15, which is equal to 30, positive 30. And this sign is very important. What are the factors of 30? 1 and 30, 2 and 15, okay, 3 and 10, and notice 3 and 10, if you add them, give 13. So I'm going to replace this. I'm going to now write this as 2x squared. This is a plus 3x, okay, plus 3xy, because it is an xy variable, plus 10xy, and plus 15 plus 15y squared. And now what we'll do is perform factor by grouping. Break this into one group, break this into the other group, and let's perform factor by grouping. So if we have 2x squared plus 3xy, what's our GCF? The GCF here is x. And on the next side, we have plus 10xy plus 15y squared. Our GCF here, plus, because this is a plus, 5y. Okay, so here are my two GCF. we broke the problem into two. So if we take out an x, we have 2x plus 3y plus 5y, the next GCF, okay, plus 5y. And then we'll have 2x plus 3y. Notice that this is identical to this. So we do have another GCF, which is 2x plus 3y. If we take out 2x plus 3y, we'll have the x left, and we'll have the plus 5y left. Okay? So here we have factored that problem, this polynomial, which looks like a quadratic. Okay, and you can consider it as being quadratic also. Okay, so notice what's the difference in your answer. In your answer before, you never really saw the y here. And that's because this thing here had a y square. Okay, that's the reason why you have those y's there. So now we want to look at some different types of factoring problems. Okay, we want to look at some different types. We could think of this example that I've just did here as one of those special case factoring. Okay, but I don't think it's special. We just write them or think of them as special factoring. But a very common one that follows is what is known as difference of squares. So you can think of this as special factoring. Okay, difference of squares. And the difference of squares, okay, is anything, any polynomial where there's obviously a difference of a squared, the difference minus b squared. It's a difference of two squares. Okay. Example, so this is the general form. Example of this would be x squared minus 4, which is the same as x squared minus 2 squared. Okay. So whenever you factor difference of squares, the factors, okay, the factors of difference of squares so a squared minus b squared, the factors are a minus b times a plus b. These are called your factors. Okay, those are the factors. A minus b, a plus b. So with that being said, suppose I ask you to factor x squared minus 25. Well, let's just go through our steps, right? Don't forget our steps. Step 1, look for GCF. There is no GCF here. Step 2, it's not a 4-term polynomial, so you can't break it up into groups. Step 3, it is quadratic, technically. It is a quadratic, but the b is 0. Okay? And the c term is a perfect square, and that's how you know it's a difference of square. So we can rewrite this as x squared minus 5 squared. And now you can factor it as x minus 5 times x plus 5. And here is our solution or factors. Okay. So once you have identified it's a difference of squares, okay, you're able to use the difference of square formula. Okay. There is also difference of cubes. There's also difference of cubes that you will have to know. Okay. There's also sum of cubes, but there is no sum of squares. Okay. There is no sum of squares. So we'll do some examples of those in a minute. Okay. Let's try a few more examples of these. How about factor? How about if I ask you to factor 81a squared minus 25b squared? Okay. Now, first step, look for GCF. Do we have anything common between 81 and 25? And then do you have anything common between the letters or the variables? So clearly there is no GCF here, okay? But if you notice, it is a difference, two terms, and this is a perfect square, this is a perfect square. So I can rewrite this as 9a quantity squared minus, I can rewrite this as 5b quantity squared, right? The square root. So you can think of this also when you look at this. Do you know the square root of 25? Do you know the square root of 81? If you know the square root, then these are perfect squares, okay? Now we can apply the formula 9a minus 5b and 9a plus 5b. The only difference between this factor and this factor here is the sign, okay? One is a minus, one is a plus. One is minus, one is plus. That's the only difference between the two of them. Only difference. Another example, factor 6x squared minus 54. Yeah. So if you look here carefully, remember, always remember, first step is to look for GCF. We do have a GCF here, and the GCF is 6. So if you take out a 6, you have x squared minus 9. And then this here is difference of squares, so this is x squared minus 3 squared. And now this, we can apply the formula x minus 3 times x plus 3. Don't forget to bring down the 6. Okay. As I said, if you're asked to factor, okay, example, x squared plus 25. Now you can rewrite this, you can rewrite it as x squared plus 5 squared, but note this is a plus, this is a sum, therefore cannot be factored. Okay, so x squared, properly, x squared plus 25 is what we call a prime polynomial. X squared plus 25 is a prime polynomial. Now there are cubics, okay, for sum and difference. So you should know the cubic. Okay? Cubic. So we need the sum and difference of two cubes. Okay. So what does that mean? 1, a cube plus b cube. Now for cube, you can factor this. This is equivalent to a plus b times a squared minus ab plus b squared. And the difference of cube, two cubes, a cube minus b cube, this is equal to a minus b times a squared plus ab plus b squared. So it is very important you will have to know these two. And there are more also, okay? There are more. So sum of cubes, difference of cubes, and difference of squares, but there is no sum of squares, okay? No sum of squares. So let's look at maybe one or two more examples and then finish up. How about if I have, let's start off with a simple scenario. Factor 27x cubed plus 125y cubed. Okay. So the first thing, do you see anything common between 27 and 125? And I don't think there is, but I do know the cube root of 27, and I do know the cube root of 125. So 27 is the same as 3 cube, right? And 125 is the same as 5 cube. So I can rewrite this as 3x everything cube plus 5y everything cube. And now I can apply the sum of cubes formula. Okay? So the sum of cubes says that if I factor this, I will have 3x plus 5y. Then I will have 3x quantity squared, right? Minus 3x times the 5y, and then plus the 5y quantity squared. Simplifying this, we have 3x plus 5y. This becomes 9x squared minus 15xy, okay, plus 25y squared. Okay. So this will take some time and some practice for you to get used to. Okay. And I'll put some practice up on the homework system for you. Okay. So I strongly suggest that you look through for more practice and practice as much as you possibly can. Okay. Because we've done a lot of examples, but the more you practice, the better you become at this. And this is very important because if you don't know how to factor, you will struggle when it comes to solving equations. Okay? You will struggle. So please make sure you learn how to factor. It's very important. Okay? Factoring is an important tool for solving equations and for simplifying rational expressions. This is a very important tool for solving equations and to simplify rational expressions. Take care and see you later.